Hello, calculus fans. All right, let's try another example. We're going to find the absolute maximum and absolute minimum of f of x equals x plus cosine 2x on the interval from 0 to pi over 2. Now we note that this is a continuous function on the interval from 0 to pi over 2. In fact, it's continuous everywhere because it's the sum of a polynomial function and a trig function. Cosine is continuous everywhere, so is x. It's continuous everywhere, so it's continuous on 0 to pi over 2. And so it's legitimate for us to use the closed interval method. All right, so we'll follow the three steps in the closed interval method. First thing we're going to find is the critical numbers. In order to find the critical numbers, we need to calculate a derivative. So the derivative of this function is 1 minus 2 sine 2x. This 2 out in front comes from the chain rule. Now we're looking for critical numbers. Remember the definition. A critical number is a number in the domain of the function where the derivative either doesn't exist or is equal to 0. Now there aren't any values where the derivative doesn't exist, so we're just going to set the derivative equal to 0 and work on that. So if we set the derivative equal to 0, then we're setting 1 minus 2 sine 2x equal to 0. So that means that sine of 2x is equal to 1/2. So let's take a step back now and talk a little bit about solving trig equations like this. So you actually spend a fair amount of time in pre-calculus working on solving equations of this form, and this is why. So let's suppose that we want to solve the equation sine of theta is equal to 1/2. So as you can see, I'm temporarily ignoring the 2x and just putting a generic argument into the sine function. So we're going to solve sine of theta equals to 1/2. Now the sign is positive in quadrants 1 and 2. All studs take calculus. So there are only going to be two solutions in the interval from 0 to 2 pi. As we said, one's going to be in quadrant 1, the other is going to be in quadrant 2. And they both have a reference angle of pi over 6. That's based on this equation. Sine of pi over 6 is 1/2. So obviously the first angle is just pi over 6. The other one is a second quadrant angle whose reference angle is pi over 6. And so that's going to be 5 pi over 6. So those are the two values that we get, at least between 0 and 2 pi. Well, let's say we wanted to keep going outside of the interval from 0 to 2 pi. So we can actually say that all solutions of sine theta equals 1/2 can be written like this. Once we have the two solutions that are in the main interval of 0 to 2 pi, then we can just tack on multiples of 2 pi to get new solutions. So theta equals pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k actually will tell us every possible solution of this equation. We should mention that k is just any integer. Could be positive or negative. So now let's go back to solving this equation here. So we know that theta is equal to pi over 6. Theta is 2x, so that gives us this equation here. And if we solve that, then we get pi over 12. This guy here. Now, what's the next value? Well, our next solution of sine theta equals 1/2 is 5 pi over 6. And so that's where we get this guy. And of course, that gives us x equals 5 pi over 12. Now we can keep going. Our next value would have to be pi over 6 plus 2 pi. And so that tells us that x would have to be equal to 13 pi over 12. If you go back to the statement of the original problem, we were only dealing with an interval from 0 to pi over 2. So this value of x is not in our domain, so we're going to throw it out. What that means is that there are only going to be two critical numbers, pi over 12 and 5 pi over 12. So that handles finding the critical numbers. All right, so now let's find the value of the function at the critical numbers and at the endpoints. So we're going to plug in 0 and pi over 2, those are the endpoints, and our critical numbers, pi over 12 and 5 pi over 12. Okay, so the first endpoint, 0, we get an output of 1. If we plug in the first critical number, that's pi over 12, then we end up with pi over 12 plus cosine of pi over 6. And of course we know that cosine of pi over 6 is equal to square root of 3 over 2. Now we'll plug in the other critical number. That's 5 pi over 12. This time we end up with pi over 12 plus cosine of 5 pi over 6. And we know that cosine of 5 pi over 6 is negative root 3 over 2. And finally, we'll plug in the rightmost endpoint, that's pi over 2. This time we end up with pi over 2 plus cosine of pi. And we know that cosine of pi is equal to negative 1. All right, so let's take stock of what we have here. We've calculated 4 output values. And we need to compare these now. We need to know which is largest and which is smallest. Now, with a lot of work, we could figure out which one is largest and which one is smallest without using a calculator. But at this point, probably the most efficient thing to do is just to take all these numbers and plug them into our calculator and see what we get. So let's go ahead and do that now. Because what we want to do now in step 3 is to find the smallest and largest outputs. We're going to make a comparison between those by plugging these values into our calculator. Now the first one was 1, so we don't need to make any comparison with that. And so the other 3 values we plug into our calculator, and these are the numbers that I got. So we're looking for the largest and the smallest. So the absolute minimum is this one, and the absolute maximum is this one. Now keep in mind that 1 was one of our output values, but that's neither the largest nor the smallest. Okay, so we've got our answer. The absolute minimum is 5 pi over 12 minus root 3 over 2. That's about equal to 0.44. And that occurs at 5 pi over 12. That's what we had to plug in to get that output. The absolute maximum is pi over 12 plus root 3 over 2. And we had to plug in pi over 12 to get that one. So there we go. We've got our absolute minimum and absolute maximum. That's all for now.